lesson today is examples on lesson 4, unit 3. This lesson concerned with the properties of the parallelogram and special cases of a parallelogram. Now we transfer into example 1. Example 1, in the opposite figure, AD is parallel to CE. Look at the figure. AD is parallel to CE. AD is parallel to CE. Number 2, measure BA bisects angle DBE. BA bisects angle DBA. Now BA bisects angle DBE. That means measure of angle ABE equal measure of angle ABC. Measure of angle ABE equal measure of angle ABD. Yes, measure of angle DABD equal 50 degree. Now measure of angle ADB equal 50 degree, and the measure of angle C equals 65. What is the required? The required is prove that ABCD is a parallelogram. ABCD is a parallelogram. From the properties of the parallelogram, ABCD is a parallelogram if each two opposite sides are parallel. Each two opposite sides are parallel. Now we have AD parallel to CB from the given. And now we want to prove that BC is parallel to AB. We can prove that BDC is parallel to AB by finding one of the following: two opposite angles, two corresponding angles equal in measure, or two interior angles, their sum equal 180, or two alternate angles equal in measure. Now we will transfer it into the proof. Proof: since DA parallel to CE, this is number 1. DA is parallel to CE, it is given. And also since measure of angle ADB equal 50 degree. Measure of angle ADB equal 50 degree. But therefore, measure of angle DBC equals 50 degree also. Alternate angles. Look to the figure. ADBC forms the letter Z. ADBC forms the letter Z. Therefore, measure of angle ADB equal measure of angle DBC equals 50 degree alternate angles. But we have BA bisects angle DBC. To find the measure of each angle from the bisector, we can calculate the measure of each one by using the rule 180 minus 50 divided 2. Then we have measure of angle ABE equals 180 minus 50 divided 2, which equals 65. Now we have measure of angle C equals 65, and the measure of angle ABE equals 65 also. But these two angles are corresponding angles. Yes, this angle ABE and the angle C are two corresponding angles and they are equal in measure. Yes, then we have AB equals or parallel to CD. AB is parallel to CD. Therefore, we have AD parallel to BC and AB parallel to CD. Therefore, we have H2 opposite sides are parallel. Then we can say that ABCD is a parallelogram. Now we will transfer into example 2. Example 2, in the opposite figure, ABCD is a triangle, and measure of angle B equal measure of angle C, and AD bisects angle A. That means measure of angle DAB equal measure of angle DAC. Now we want to prove that length of AB equals length of AC. Now we have in the opposite figure, we have two triangles, which are ADC and ADB. What is the relation between two triangles? In two triangles, we have measure of angle B equal measure of angle C from the given, and measure of angle DAC equal measure of angle DAB from the given also. And the AD is called a common side. Then we have two triangles are ADC and ADB are congruent because they satisfy the three conditions of congruency. Then from congruency we can deduce that AB equals AC. Now we are in example 3. In the opposite figure, we have AB and DE are two perpendicular straight lines on BD, and measure of angle A equal 30, and the measure of angle D equal 120. Now we want to find measure of angle E. Our proof starts from triangle ABC. Look at the figure, triangle ABC. We have measure of angle B equal 90 and the measure of angle A equal 30. Then we can calculate the value of angle ACB, which equals 180 minus 30 plus 90 equals 60. Then we have measure of angle ACB equals 60 degree. Then also we have measure of angle DCO equal 60 degree also, because they are vertically opposite angle. Yes. Now we will translate into the quadrilateral DEOC. In this quadrilateral we have measure of angle D equals 90 degree, and the measure of angle O equals 120, and the measure of angle DCO equals 60 vertically opposite angles. Then we can find measure of angle A by knowing that the sum of the measures of any quadrilaterals equals 360. Then we can find the value of the measure of angle E from the following relation, which equals 360 minus 90 plus 60 plus 120 equals 90 degree. Now we will translate into question example number 4. Example number 4 states that the opposite figure ABCD is a square and the AC parallel to DE. And here we have two required. The first required is prove that length of CE equal length of BC. Length of CE equal length of BC. The second required is find measure of angle ADE. ADE. I want to find the measure of this angle. Our proof to find the first required. Since ABCD is a square, then we have AD, length of AD equal length of BC from the properties of the square. Yes. Then we have also AD parallel to BC from the properties of the square. Then we can say that AD is parallel to CE also. Yes, because AD parallel to BC, then AD also parallel to EC. Yes, then we can say that the quadrilateral ACED is a parallelogram. Yes, because H2 opposite sides are parallel. Yes, and equal also. Yes, from the properties of the parallelogram, H2 opposite sides are parallel and equal. Yes. Then we have AD is parallel and equal BC. Also we have AD is parallel and equal EC. Yes, from 1 and 2 we can deduce that the length of EC equal length of BC because each of them is equal to AD. This is the first required. QED1 means this is the first required. Now we will translate into the second required. We have, or we know from the properties of the square, the measure of each angle is 90 degrees. Yes, but we have AC is a diagonal, and from the properties of the square, the diagonal bisects the opposite angle. Then AC bisects the angle C, but the measure of angle C equals 90. When we bisect angle C into two angles, then the measure of each angle equals 45 degrees. That means measure of angle DCA, this angle, its measure equal 45 degrees. By the same way, measure of angle DCCDE or EDC equals also 45 degrees, alternate angles. Then we have the measure of this angle equal 90 degrees and measure of this angle equal 45 degrees. Then the measure of ADE equals 45 plus 90 equal 135 degrees. This is QED2 or the second required. Now we will translate into example 5. Example 5, in the opposite figure, we have DH is parallel to BC and measure of angle D equals 70 degrees and measure of angle B equals 40 degrees. What about the required? The required find measure of angle. The required is measure of angle BAC, this angle. Yes, from the given, since DH is parallel to BC, yes, and since the measure of angle, since the measure of angle D equals 70 degrees, therefore measure of angle C equal also 70 degrees, alternate angles because they form a letter Z. Yes, letter Z. Yes, this is 70, therefore measure of angle C is also 70, alternate angles. Look at to the triangle ACB. Look at with me to triangle ACB. Now we have in this triangle measure of angle B equal 40 degrees and the measure of angle C equals 70 degrees. Now we want to calculate the measure of angle A. We know that the sum of the measures of the interior angle of any triangle equal 180. Then we can calculate measure of angle A from the relation 180 minus 70 plus 40 equals 70 degrees because they are angles of a triangle. This is the end of our lesson. Thank you, goodbye, and good luck.